First of all, is Scott here? No, that dude owes me. Okay, so before I start the talk, I want to thank EngineYard. Yeah, it works. Okay, because basically they're paying for my trip here. So without them, I wouldn't be here. So thanks, EngineYard. Yeah, I already was introduced. I'm Konstantin. I just graduated at that institute down there in Germany. That's where I'm originally from. I have that insanely long Twitter handle. So the easiest way probably is go to my website and click on the Twitter link instead of typing that, in case you want to follow me or just check out the nonsense I'm writing there. As said, I maintain Sinatra. I'm also about to have a book published. It's actually supposed to be released at the end of this month, but I just got an email from my editor saying, oh, I just asked a few things and I have about 200 notes in the book. I wrote it together with Alan Harris, great guy. Yeah, I'm also on the rec team, and I've spent the last 3 months working more or less full-time on Rubinius and related projects. If you don't know what that is an alternative Ruby implementation. Definitely worth checking it out. Better threading support, better garbage collector. Most of it is written in Ruby, and so on. Oh, I have a timer here that I didn't set on. Okay. So, but the real question is, who's the best soccer player? No, actually, that's not the real question. So why would you look beyond Ruby? So my talk is about looking beyond Ruby, so I will mainly talk about different programming languages and different stuff they're doing. And one of the reasons to actually wanting to do that is to broaden your horizon as a developer. I don't want you to leave Ruby. I want you to improve Ruby, both the language itself and how you use Ruby. So in the end, you become a better and more experienced developer. I want you to go out and explore. By the way, that's, in case you don't know, that's Matt's daughter. He gave a talk yesterday. Yeah. And I think you're all by now pretty impressed with my Spanish on the slides. That's because I use Google Translate. Yeah, you might wonder why I don't speak Spanish, yeah. But, well, faking it is a bit like if I'd pretend to speak Japanese, you know. Okay, let's get serious. Okay, so the goal of my talk is to tell you something new. So there will be no Erlang, there will be no Go, and there will be no Clojure, because I personally have that feeling that those are great technologies, but they've been covered from conference to conference, and so I didn't want to duplicate anything you might have heard. There's pretty good documentation out there, and also there will be no Node.js. I'm not really too excited about that. Yay, JavaScript on the server side. Okay, no. But it's fine, I don't have anything against it, but it's not really that horizon broadening, in my opinion. Okay, so first thing I want to talk to you about is full object orientation. Being 100% object oriented. But you might say, wait, doesn't Ruby do that already? Everything's an object. Don't we have that? Well, if you look into the subject, turns out object orientation is not the same as object orientation. Basically, there are two different definitions of object orientation. One is the one you probably learn in school. That is, objects are data and functionality. Or if you don't have it in high school, then in the first semester in CS, or the first sentence in Wikipedia, if you look it up or something. So But if you look at the history of object orientation, then that term was actually invented by a guy called Alan Kay, who is one of the inventors of the original Smalltalk. And he defined it differently. So, first of all, this is the what you generally call the Simula-based definition. So that's basically the object orientation you would follow if you write Java programs or C++. And Alan Kay said about C++, actually, I made up the term object-oriented, and I can tell you, I did not have C++ in mind. Okay, but what did he have in mind? Object-oriented programming to me means only messaging, local retention, and protection and hiding of state process, and extreme late binding of all things. Okay, seems a bit fancy or a bit boring, don't know. So the basic idea is messaging. So all you have are objects. Everything's an object. And all you can do with those objects is send messages to them. There's no other way to interact with those objects. And in return, you'll get an object again and can send messages to it. Well, that still seems like we're doing that in Ruby, right? But look at this example. There's a message sent here, the equal sign. But overall, I see 3 constructs in here that are not message sends. But how should that work? How should if become a message send? Well, since Alan Kay invented Smalltalk when basically coming up with the principle, let's look at what Smalltalk does. Smalltalk, it sends messages. Actually, it sends only one message because it has keyword arguments, but you don't have to focus on that too much. If you have ever done Objective-C, then you're familiar with that. It could also be 2 message sends, it doesn't really matter. So basically, what you have is, you have this object and send a message to it, asking if it equals 42. And this term will either return true or false. And then to that true object, it sends the message if true, if false, with blocks in here, and then the true object will actually execute the correct block. Now, if you'd like to do that in Ruby, here's how you do that. Defining if true on true and just call the block passed, and defining if true on false and just doing nothing. You do not need branching as a low-level language construct to do that. Well, actually, there's still some things in here that are not object-oriented, because since you should only interact with objects by sending messages, you should actually send messages to true, or more specific to the class of true, telling it to define a method. That is what it looks like if you would do only message sending in Ruby. It's a bit strange, and I don't encourage you to write the code like that, but it's something to think about and to get a feel of, because it will improve your Ruby. And the good thing about that is that you can duck type it. So you can basically create an object that behaves like it was false without having to change anything in the language. And that's one of the biggest advantages of just having message sends, is that you can fake anything. So for instance, it is pretty hard to duck type hash in Ruby or any other object if somewhere in the code a case statement is used, because case is actually using message sends internally, but it's case will send a message to hash, not to the object X. So this example is, this is just something I made up. Imagine X is some object that pretends to be a hash, and then there is a case statement somewhere, and the hash should be executed if it is a hash. And so if it would be 100% object-oriented, then the only means Ruby internally would have to figure out if it's a hash, is sending messages to X, instead of what it is actually doing is it takes the struct in memory and inspects it and checks the class in there. And seems a bit hypocrite to talk about that, but that's actually an issue in existing code. For instance, WebRig checks the return value of the application, and only if it is a real I/O object does it streaming. That is why all the streaming examples with reg work on all servers but WebRig. And basically, don't treat your objects like data structures. Treat your objects like objects. What I mean by that is, do not access their internal structure too much, especially if you're interacted from the outside as a kind of API. Rather, think in terms of sending messages to those objects and waiting for the response. That will also decouple the internals from the API and give you more modular software. Here's the quote again. He says a few more things in there. One thing he mentions is extreme late binding. That means before you actually send, you do not decide what code will be executed before you actually send the message to the object. So you can change it at any time. Now, generally Ruby does that, but there's one issue. I don't know if you've seen it, but there's a Ruby specification now. And that specification now says that you don't have to do that, basically. So for every built-in method, Ruby does not have to send a message call. In this case, even if a program redefines the method, the behavior of the program might not change because the redefined method might not actually be invoked, which violates late binding. And it kind of means that every built-in Ruby method could actually be a keyword, you know? It's just something to think about. Let's explore this a bit further. Is Smalltalk object-oriented? Well, it seems so, from what you've seen so far. Has anyone in here ever done Smalltalk? Oh wow, that's cool. So, is Smalltalk really object-oriented? Yes or no? Shout, raise of hands. Yes. Okay, I thought so too. Now here's the painful truth. Variable and constant accesses are no method sends. Okay, that seems a bit weird. Why would they be? But, well, let's go on. Self or super is no method send. Same goes for true. True is no method send. Well, also, all the Smalltalk implementations that are out there to cheat on you. No implementation treats if true actually as a method send. Open your Smalltalk and try to redefine that. It won't work, I tell you. And constants are not late bound. That's basically not too much an issue because Smalltalk recompiles everything if you define a new constant. But if you want to do fancy metaprogramming, that is an issue. Okay, but let's not talk too much about that. Let's talk about the language here. Okay, who of you has used Newspeak? Who of you has heard of Newspeak? The programming language, not the language from 1984? Okay. Okay, so Newspeak is an experimental language by Gilad Bracha. He was really big into writing Smalltalk VMs and was involved with the original Java specification and is now working on Google's Dart project. And in Newspeak there are only method sends. There's nothing but method sends. And there is no global state either. But, okay, so first thing, for a moment, just imagine in Ruby, you only had method sends. You didn't have constant access, you didn't have variables, not anything. That would be kind of strange because like everything that you send would have to be defined as a method on the class or in some class you inherit from, but you actually want lexical scope. And what I mean by that is, if you have code like this, where you define a constant up here and access it here, you actually want this method to find that constant, even though it doesn't inherit from this part up here. So, but if foo would be a method send, then it would look up foo and bar, and then the superclass of bar which would be object. And in that case, it might, if this would define a method on object, then it would work. But imagine you had a nested class. Like, in nested, it would look up inner on nested and wouldn't find it, and then look it up on object, which might end up here, and it wouldn't find it. So that wouldn't work either. But we actually want that behavior because that's how we program. That's rather comfortable. So what Newspeak does is it has a pretty clever, so it seems rather simple to dispatch from the outside, but I implemented it on the JVM with Invoke Dynamic, and it is not simple, not at all, and it's bidirectional. Let me explain what I mean by that. So in Smalltalk you have, in Newspeak, you have a construct like this. You have a class that is nested in an outer class, and that's all in this package. And since you do not have global state, you import some classes from a so-called platform, and that platform is what offers you, for instance, the object class everything inherits from. That platform can offer you a file class to access the file system and so on. And that way you can do pretty simple sandboxing too. And then you can have your classes inherit from the nested superclass. And a normal Ruby lookup would go like this. Start in the nested class. If you don't find the method, look in the superclass. But what Newspeak is doing is it offers two different dispatches depending on whether you have an implicit receiver. Say, if you would say foo, then it would have an implicit receiver, and it would look like it would be a constant. So what it does is it looks it up in the scope it's nested in, and if it doesn't find it here, then it treats it like a normal method and looks it up in the inherited scope. And if you have a receiver, like if you say self space foo, because space is the separator, not dot, then it would actually just look it up in the inherited in the inheritance chain. Now the interesting thing is that self itself would be a method call, but it would find the implementation of self basically going up here, going all the way here, up until you hit the original object where self is defined, which does some interesting things because you could override self and do crazy stuff, you know. Okay. Who's still following? Okay, some. Okay, let's talk about something else. There are so-called homo-iconic languages, and if you've heard a talk about José Villem, he's actually requesting features he wants to have in Ruby, and that is something he wants to have, or something similar he wants to have there. Let's again have a long, nasty definition. In computer programming, homo-iconicity is a property of some programming languages in which the primary representation of programs is also a data structure in a primitive type of the language itself. From the blah, blah, blah. This makes metaprogramming easier than in a language without this property. Okay, let's look at this. The primary representation of programs. That is basically a fancy term for your source code. So your source code is supposed to be a data structure in a primitive type. Primitive types are all the types you can write as literals, like a string would be a primitive type. an array would be a primitive type, and so on. And this is supposed to make metaprogramming easier. Let me show you. There are a few languages that implement that. The most famous one is Lisp, and there are a few others. I didn't really know that Prolog was more iconic, or I didn't think about it in that way. And then, if you come from a Ruby background, I highly recommend you checking out IO or Ioki, which are pretty similar to Ruby. And then there's José's new pet project, which is the Lego programming language. You can find it on GitHub. So, but Lisp is like the most common example for this. It's very into parentheses, and that's because the basic data structure of Lisp is lists. This is a list, like you can imagine it as an array with the elements 1, 2, 3. Now the fun thing is, this is a program in Lisp where the part up here is a list again, but that list will be executed. It is actually and the prefix notation means it will add 1 and 2, and this is a comment just to demo you the result. It will be evaluate to 3, surprise, surprise. And well, you can also kind of define values. This would set b to 23, and from there on, if you use b in an expression like this, then it would evaluate to 23. And then you can do, this is a Lisp crash course. Who here in here has used Lisp? Oh, okay, nice. So, and then there are two essential, really important operations for working with Lisp. They are called car and coulter, which allow you to interact with lists. Car allows you to access the first element in a list, which in this case will return 1. And coulter allows you to access the rest of the list, which in that case would be a list including 2. So if it would be 1, 2, 3, this would actually contain 2, 3. And so if you want to access, for instance, the last element of this list, you first get the rest of the list and then access the last, and then say, give me the first element of the rest, which in that case would be the last element. Yeah, and it stands actually for contents of the address part of register number and contents of the decrement part of register number. So the pretty low level stuff you actually got from building machines, register-based machines. Okay, and now the fun thing is that since lists are programs, you can just define them as lists, store the lists in a variable, and then just evaluate that list later on. And this might seem like, well, oh, eval, but the thing in Lisp is you actually call eval a lot, especially in the internals, because you don't actually do parsing and compiling or anything at that point, since the thing you pass in is actually already a list. It's actually more like if the program starts, it works down into the list until it hits a list that's not to be evaluated, which is, say, by the what do you say, by the colon? Okay. and then with the eval, you just say continue walking into that list. So that's what you use for control flow. And yeah, you could also, instead of evaluating that list, now take that list, modify it. So go in, access the rest of the list. No, access the rest of the list down here, which would be B23, then access the rest of that, which would be a list with 23, then access the first element of that would be 23, and replaces with 42. And then if you run the code down here, it would actually evaluate to 42. So if you've never seen that, it might be a bit hard to wrap your head around all that. But it's actually quite useful. So you can use that in turn to implement macros, which allows you to implement basically about any feature that was not covered in here. Any language feature that you could imagine could be implemented in the language itself at runtime. And you can use that for partial evaluation to optimize your program. And yeah, it allows you to extend the language from within. One last thing I want to show you, in case that wasn't too much already, is declarative programming. You have that in languages like SQL, XSLT, SparkQL, and Pig. What? Did the last slide just say SQL and XSLT? I mean, seriously? And that's what I want to talk about? Well, actually, no. Declarative programming can be fun, because those are not the only languages doing declarative programming. There are actually Prolog and Erlang. Who of you has used Erlang? Okay, Prolog. Whoa, more people have used Prolog. Okay. I should have talked about Erlang instead. Okay, so Prolog is a language for defining expert systems, where you basically say those are the facts and the rules, and then you can ask Prolog to tell you something about the world you've just described. And the fact looks like this. Tenderlove is in Ruby core. This is the fact definition, and then you can query the system and ask, is Tenderlove in Ruby core? And it says yes. And then you say, give me someone who's in Ruby core, and it says Tenderlove. That becomes pretty handy if you combine it with rules. So you can define two facts, like Tenderlove is in Ruby core and Tenderlove is in Rails core. And then you define a rule for anyone who is in Ruby core and Rails core is Uber core. Then if you go there and ask the system, who is Uber core? And it says Tenderlove. You could of course also ask, is Tenderlove Uber core? And it says yes. Or you could ask, is that Shaw Uber core? And it would say no. And well, that does seem like a pretty, like you can't do much with it, but actually it's pretty powerful. You can use that, for instance, to solve your Sudoku riddles. Who doesn't want to do that? And well, you could actually use it like Lisp, because it also has options to interact with lists. So let's define rules for car and coder, just to show you how you would interact with data structures and complicated systems. You have this notation for lists. Lists actually look like arrays in Ruby. And then you have that syntax for defining. This is actually saying H should be the first element of a list, and I don't care about the rest. And this is saying I don't care about the first element, and T should be the rest of the list. And the interesting thing is that you can reuse those variables in the definition, so you don't actually have to apply any add any rule logic, because this fact would be true if the second element you hand in is actually also the first element of the list, and this fact would be true if the rest of the list is also the second element. So what you can do is, like asking for who's Ruby core, you can ask what is the rest of that list, the first element of that list, and that would only be true for one. And you can also ask what is the last element of what is the rest of that list, and it would return, or it wouldn't really return. It would be true for 2 and 3, and that's why X is the solution for that. If you would hand in a list with 2 or 3 in here, then it would just say yes, and if you would hand in 5 or something in here, then it would say no. That's basically how you program in Prolog. And that is kind of neat for some solutions. So you can actually implement list sorting like that. You do not define how to sort a list. You only define what a sorted list looks like. And a sorted list, so an empty list is sorted, so that fact is true. A list with just one element, and you don't care what element that is also sorted. And a list that starts with 2 elements and then has more elements after that is sorted if the first element is smaller than the second, and and if the rest of the list, excluding the first element, is also sorted. So you could hand in a list and sort it, and it would say yes or no. And then you can implement a sort fact that evaluates to true if the second element you pass in is a permutation, a reordered version of the first element, and is also sorted. And now if you leave this one empty, like with a placeholder, then it would return to you the sorted version of the list instead of saying yes or no. And the fun thing is that you could pass in a sorted list and ask for an unsorted version, and then it will just give you one and say, do you want more? And then you can say yes, and it will give you another, and it will continue until there are no more lists there, no more versions, which is kind of neat for problems with more than one solution. Okay, I have one last question for you. Who didn't learn or see something new? Cool. Then I'm happy with that talk. I hope you liked it. And thank you. Are there questions?
¿Preguntas?
There.
Sí, mostraste un montón de lenguajes nuevos y... Well, okay. I can ask you in English. You talk about lots of interesting languages, and I was thinking, which one would you choose? Like,
it depends.
Ruby is your favorite one, but if for real life, like.
Okay, for real life, my favorite language is Ruby.
Beside Ruby.
That actually depends on the problem, because they are all pretty problem specific. I've done a lot in Smalltalk, and I wouldn't like, if I have a project, implement a website or implement that application, I wouldn't go for Lisp. But if I have a project that would demo some language implementation stuff, I can well imagine doing that in Lisp. And I would actually love doing something in Prolog, but has one of you ever had a use case for like a real world application where you said, yeah, let's do that in Prolog? Exactly. I wouldn't go for Newspeak, because Newspeak is really, really complicated. I would try to implement something in Newspeak, but I wouldn't like set out to implement a real production application in it.
Thanks.
¿Alguna otra pregunta? No. Listo.
Should I put on the translation thing?
Yeah, sure. It's ready. So.
Hi, Konstantin. I'd like to know your opinion about Haskell.
Oh, it's English. So I like Haskell too. I'm not really able to write programs in Haskell, but I've looked at it and heard it talk about pattern matching and so on. It's really interesting, like to wrap your. I think it's really cool for like provability and so on, and to. I mean, did you see the quicksort example in Haskell?
It's
So,
great.
but the thing is I'm not sure if you can really learn. So if you start from, I want to improve my Ruby, then it's a pretty long way to go to Haskell, and then from that take something out that improves your Ruby. But yeah, sure, it's an interesting language too.
Thank you.
Yeah, can you talk about Rubinius, like kind of any, I don't know, I'm just curious why you're up there, anything that, like where it's at or what?
Okay, so Rubinius 2.0 is about to be released. So Rubinius is an alternative Ruby implementation with a small virtual machine written in C++ that compiles to that does a JIT that compiles to machine code, and the rest is written in Ruby. And it's really far ahead, so it basically runs, if you have a normal Ruby application, even if that's doing crazy stuff and relying on some weird behavior, internal behavior, and has a ton of C extension, that should still work on Rubinius and run pretty well. 2.0 is about to be released, which does no longer have a global interpreter lock, and there will actually be big production apps running on Rubinius soon. So I think it's ready for prime time for using that, not only for development, but also for running your application on your server.
Hey, when you mentioned about Prolog and if it had any real use cases, I actually thought no, that it's just an academic thing. But these guys here were saying, and apparently they're too afraid to talk or something. But do you know Genexus? Okay.
No.
So it's a code generator thing that generates horrible code, but a lot of people use it in production. But apparently the code generation stuff, it's really in Prolog.
Okay.
They make
so, I mean, there are a few things about Prolog. I think it's used for expert systems too. At least I've heard that. I'm not sure what kind of expert systems, but for rule engines, for I think for a while it was even used in computer games for like deciding if it was a valid move and so on, and how that evaluates. And the technologies used in Prolog are also used in games like backtracking implementations and so on, but that would be a bit far to get into right now. Okay. Thanks for showing up.